Hello, this video is on adding polynomials. Before we can get into how to add polynomials, I want to introduce you to some vocabulary so that you understand what I'm saying in the video. Once we learn the vocabulary, it's really just a simple thing. I'm going to show you a couple examples that should make your life easier, hopefully. And we'll just wait for that to catch up, okay? I'm gonna make this a little bit bigger. You don't know this, but I have tried to make this video approximately 3 times. So I am hoping that I can successfully get through this video. All right, a polynomial is the addition or the sum of monomials. So I've talked about terms in previous videos, and a polynomial is made up of the addition of terms. So we have monomials, that's just one term, binomials, that's two terms, trinomials, that's three terms, and so on. And when we add polynomials, we need to know what a like term is. I've talked about terms, but I haven't talked about like terms. So like terms have the same variable and the same exponent. Some examples of that are x and 2x, 3x squared and negative 4x squared, xy to the third, and negative 10xy to the third. So I'm just kind of making up what is called coefficients. The coefficients do matter when we add, but as far as determining whether something is alike or not, you're focusing on the variable and the exponent, okay? So if you're just looking at two terms and you're trying to decide if they're alike or not, you have to look at the variable and the exponent. If they are alike, then you can add them. So variable, exponent, those are alike. Variables, exponents, those are alike. So these are all examples of like terms. When terms are not alike, they have, for example, different variables. Or they have, for example, different exponents. Or both. Where they're not the same. So while we do have x and y in both of these, their exponents aren't the same. These are, but the x's aren't. So they have to be the exact same for them to be alike. And when you add like terms, you just add their coefficients. So you might be thinking, I know I've changed the exponent on something before, why don't I do that now? The only time the exponent is going to change is when you're multiplying or dividing. When you're adding, you're just looking at that coefficient. So if you can kind of think of it like M&Ms, if you have red M&Ms and blue M&Ms, if you added them together, you have red and blue M&Ms. Whereas if you have Skittles and M&Ms, it's like, ew, have you ever added those together? That's gross. You don't really want to add those together. You have Skittles, you have M&Ms. They're separate. They can't commingle. Weird example, but you kind of get my point. So what's happening here is, for example, if we have, I'll do something simple, 3x plus 5x, they have the same variable with the same exponent. So what I'm going to do is add their coefficients to be 8x. So we're just totaling the x's, kind of like the M&Ms. We're totaling the M&Ms. If you have 3 blue M&Ms and 5 blue M&Ms, you now have 8 blue M&Ms. So you can substitute your favorite candy in place of x and think of it that way. I love Sour Patch Kids. So if you have 3 red Sour Patch Kids and 5 red Sour Patch Kids, I now have 8 red Sour Patch Kids. So that's how you do it. Very easy. There's two ways you can look at this. Vertical and horizontal. I like both. I'm okay with both. I am more used to this but I am going to show you both, and you can choose which one that you like the best. So vertical is like a ladder. You stack them. And what we have here is two polynomials indicated by the parentheses being added. So addition is really easy. We're really just adding. I'm going to stack. I'm going to write the first polynomial. And then I'm going to stack the like terms with, whoops, whatever they go with. And you'll notice that I kind of staggered these. I didn't stack them. Why not? Why wouldn't it make sense to stack -3 and -3p to the third? They're not like terms. I don't want to put them together because they're not alike, so I've separated them vertically. And then when you're adding, you just add straight down. So this is a 0 up here. This would be a 0 right here. You don't have to put 0, but if you want to put a placeholder there, you can. So we're going to add those, add those, add those, and that's your answer. You could put them in order if you wanted to be -3p to the third plus 7p squared minus 3. But this answer here is fine. It's not in order. It's not in descending order, but it's fine. And then horizontally, since we have addition, I can just drop the parentheses because none of the signs are going to change. I have 5p squared minus 3 plus 2p squared minus 3p to the third. And basically what I do here is I kind of circle like terms. Those are my only two like terms, so I'm going to add those. And then everything else just stays the same. So in either case, you get the same answer. It just looks a little different. Okay, pause it, try the next one both ways, and then resume the video. So if we were to stack these, I'm going to put the 2 under the 4 and the 5 into the third under the 2 into the third. And then I'm just adding. So I get 6 plus 7 into the third. And that's it. And then horizontally, we can drop the parentheses because we're just adding. And then I'm going to circle like terms, underline the other ones, and then add. And that's it. Easy peasy. So that's adding. I'm going to skip down to subtraction. This next one, it has 3 terms, it's trinomials, but it's the same method. You're going to stack them, add them, super simple. I do want to show you this one though. We have subtraction instead. So if I'm going to write this vertically, I'm still going to stack the like terms, but I have a minus out here. So I'm still going to write it just like it looks. But this minus out front means that I'm subtracting both of these terms, not just one of them. So I'm actually going to rewrite this to make my life a little bit easier. A to the third. This one doesn't change. But this one, I'm applying a negative to both terms. So it becomes a positive 4a to the third and a negative 3a squared. And now I can just add them. You can leave it like this and apply the negative in your mind. I would be a little careful about that because you might lose it if you're not staying organized. I would recommend going ahead and distributing that negative to both terms and then just adding. That way you don't lose track of anything. And we get 5a to the third minus 5a squared. So this minus indicates that I'm subtracting the whole parentheses. So I'm subtracting both terms, which changes the signs of each term. And then horizontally, I'm going to subtract both terms. So I have a to the third minus 2a squared. That one's fine. I'm subtracting 3a squared, and I'm subtracting negative 4a to the third. So I'm going to simplify a little bit. This minus a negative becomes a positive. And then we have like terms. And that's 5a to the third minus 5a squared. So you can see that I did it two different ways, but I got the same exact answer. So you can choose if you like the way on the left, the vertical way where you stack them, or if you like the way on the right where you're writing it out horizontally. Whatever method works for you the best is the method that I want you to use. I'm more inclined to use this method. It makes more sense to me. It looks nicer to me. But if you like this, if stacking it makes more sense, then do it that way. I love it. I love both ways. I just like this is more natural to me to do it horizontally. So you'll probably see me use that more often. Let's go to the next page. Ooh, I want to skip down to this one here. This would be more of the same. You would have to distribute that negative. But I'm going to skip down here for the sake of time because I want to cover this. Look how fun that is. 3 of them. We're adding 3 polynomials. So this one is vertically, so I'm going to stack my like terms vertically. You're going to have to be real careful with keeping track of your terms. And also there is a negative right here, so this is going to be distributed. I'm going to distribute before I start stacking them because I'm a little nervous about losing my negative sign in the process. So minus a negative becomes positive, minus gets applied here, minus a negative becomes positive. And now I'm going to be using those terms when I start stacking all my terms, okay? So I have 4x squared, I have a negative 5x squared, and I have a 9x squared. So what I did was I went through each of my polynomials and I was trying to see if there were like terms with x squared. So my first one was 4x squared, here's a negative 5x squared, and a 9x squared. Now I'm going to go through and see if there's any like terms with positive 5xy to the third. There's a positive 2xy to the third and a negative 3xy to the third. And I don't have to worry about losing my signs because I distributed ahead of time. And then the last one, I have a 6y, a negative 3y, and a 2y. And then now I can just add. I don't have to worry about distributing, and I don't have to worry about the negatives. I can just add straight down. I'm going to add all the blues. 6 minus 3 is 3 plus 2 is 5y. 5 plus 2 is 7 minus 3 is 4 xy to the third. 4 minus 5 is negative 1 plus 9 is 8 x squared. Dun, dun, dun. Isn't that so pretty? I love all the colors. I kind of like it vertically that way. Horizontally, if you want to pause it and try it, you can do that. And then come back. So when you come back, I'm just going to write these out. This is might be a little messy. I kind of like the vertical way, but we're going to get the same answer, so it really doesn't matter. I'm running out of room here. I am distributing this negative to all these here. It's getting kind of messy. You can see I had to kind of go to the next line. Now I'm going to show my like terms with different highlighter colors to make sure that I'm getting every term. I don't want to miss anything. And so now we have, use green here, 4x squared minus 5x squared plus 9x squared, 5xy to the third plus 2xy to the third minus 3xy to the third. And then 6y minus 3y plus 2y gives us our final answer. I want to check and make sure I got the same thing on the previous example. Yes, yay, we did it. So there's two ways to do the same problem, and you can see that you get the same answer. Isn't that so neat? I love that. I love that math takes into consideration individuality. So I do have some examples that you can try on your own. I'm just going to go to this one. I want you to pause it and try it, and then hit play and check your answer. So you could have chosen whatever method you wanted. You can stack them or do it horizontally. I went ahead and just did horizontally. Before I added like terms, I distributed the negative. So we're subtracting the entire second polynomial, which means that I need to subtract every term in the second polynomial. So that became a minus b to the fourth plus 7b to the third plus 3. And you have to make sure that you do that because it does make a big difference. I highlighted like terms, added them with the corresponding colors, and so you should have ended up with 2b to the fourth plus 15b to the third minus 3. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please email me and I would be happy to help.